can maybe apply over here. That's like how most learning happens, actually. So 99 or 100, we'll just make them whiteboard problems, I think. All right, boards. Show me this. The first two parts are good. Pretty good. I like yours better. So your first two parts are good, and then for this third piece is what causing people some fits. Right at x equals 3, is the slope very steep or not very steep? Very steep, and then does it get more steep or less steep off to the right? Less. So what should the derivative be right up close to 3? High, right? Very positive, and then the slope is getting more or less positive slope? Less positive, right? So the curve is going up. The curve is getting more positive. That doesn't mean the slope is getting more positive. The curve is going up, but at a slower and slower rate. So you have very steep slope right here. The curve is very steep at 3, but then it's less steep, and it's less steep, and it's less steep. So the curve's derivative is going to be high and then getting lower, but staying positive. So you have to put your boards down and analyze what you have. Positive slope of about 2. So at a height of 2, like that. I like what I saw. Then slope of -1 for this next section. I like what I saw. And then this is the part that's difficult. Right at x equals 3, the slope is very steep, so you're going to be very high with your derivative. And then as you move to the right, the slope is getting less and less. Right? This is very steep, less steep, less steep, less steep, less steep. So the derivative is getting less and less and less positive. It's always above the x-axis, because you're always going up, but you're going up at a slower and slower rate. So you could draw it like that, or you could make an argument for something like this, except this is going to eventually go negative, but this is always increasing. So it's got to like bend at some point.
The second line, that's how one.
Yeah, it's a height of -1. Why? Because the slope of this line is going down 2 and over 2. Right? Yeah. So this one's fairly tough. Do you want to do another one more in line with like the level of difficulty maybe tomorrow? So this is -1, 2, 1. This is 2 comma -2. And then this is trying to be flat. And late people, Lamia, homework? Rachel? Iman? And Leah? Okay. Okay. You have something written down. Claim try. You don't have something written down. Good. For the last, why do you stop it on the edges, on the outside edges? Why don't you continue to the left, right? Now, prints. If I had something like this, then fair enough. But if this is like clearly continuing off of an arrow in that direction, then you want to continue the derivative off of that direction. Yeah. You're missing the third. That's good. That's your second and third pieces are good. You haven't dealt with the first piece that I can see. That's good. That's good. Oh, I see it now. The marker sucks. That's not your fault. That's good. That's good. Here, Lauren, you marker. Oh man, wow, that's almost.
Oh, I was very
That's good.
You want those?
Yeah, you can chuck that. That's cool. All right. So for this first section out on the left, what's the slope? 2. So height of 2, and it's always the height of 2 until you get to what x value? 0. And then you put an open circle at 0. Then from x equals 0 to the right, what's the slope? -2. And it's at a height of -2 until you get to what x value? 2. And then from x equals 2 out to the right, what's the slope? 0. So you had a height of 0. At what x values is the function not differentiable? 0 and why not? Sharp turns, which produces jumps in f prime. Let's look at one more of these. So we've looked at a couple with just like a bunch of sharp turns. Let's look at something nice and curvy and smooth. So sketch f prime. Your marker's dead. Another one that's almost done. Yeah, that's good. 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 Very nice. Not quite. So at -2, that first key point, up until then you're good, and then you kind of get backwards from the whole of what it should be the rest of the night. Because after -2, what's the slope demanded? Positive. So f prime needs to go above and then come back down like that, like that, like that, like that. No, what's the slope right at x equals 0? Good. Nope. What did the prince and an Andres was about to do the same thing? What's the slope right at x equals 0? You did the same thing as Prince and I bet. So a lot of us are doing pretty well up until you get to x equals 0. What's the slope right here? 0. Right? So the curve is flat at -2. Most of us are dealing with that properly. The curve is flat again at x equals 0. So what should be the height of the derivative at x equals 0? 0, which means we need a point at the origin on the derivative. So a lot of us are doing this, And then you're not coming back down to the x-axis fast enough. You got to come back down to the x-axis here because the slope is 0 at 0. There you go. And then continue on your way. So you can figure out the rest of it. No. So you're doing exactly what I was addressing just now. Oh, wait. No. I was looking at the wrong graph. All right. So now, what's the slope between 0 and 2, Akshay? The slope is negative because the curve is going down. So what's the derivative going to be? Below. So you got to go under here. Like that. And Tanika, what you're erasing is actually really nice. That's good, that's good, that's good. That works. So the slope here, the curve is decreasing on this interval, so you're going to go below the x-axis. And then the slope is 0 again at x equals 2, right? The curve flattens out there. So we're back to a derivative of 0 by the time you get to x equals 2. So you got to come up. And then after x equals 2, we're only going up to the right. So the derivative is positive again. Grace?
Does it matter how like the curves are?
Not really. So if you have this and then your neighbor does something like this, I'll accept both of those. Like we don't really know just from a sketch how high the derivative or how low the derivative gets. If you have the derivative on the right side of the x-axis where it needs to be, and at a height of 0 when it needs to be, then I'm going to say, hey, you have the basic sense of what's going on. All right. 88. Lucas, do you want to turn it on? Well, we don't need the light off right now. Just turn that on. If your functions are the same, except for a constant, that's what this is saying. So f of x and g of x are the same thing, except one of them has a different constant than the other. Will their derivatives be the same? So true or false, write it down, hold it up. Yay! Why? Because c goes to 0. 0 is just a constant. So when we take the derivative of both sides, you know how like when you do something in an equation, you just got to do the same thing on both sides and we're fine? That applies to differentiation. As long as you do the derivative on both sides, the equality remains the same. So if you take the derivative of the left side and you take the derivative of the right side, what's the derivative of the constant? 0. Does plusing 0 really add anything? No. So yeah, that's true. Let's stay here with 89. True or false? Write it down, hold it up. Mostly good. So mostly hooray. It's false. So why? What is pi? Constant. Specifically, it's roughly what? 3.14. And therefore, pi squared is about what? 9, 10. So you could just as easily write y equals about 10. So that's a constant, right? If pi is a constant and pi squared is a constant, we know what it is. It's about 10. And so the derivative of that is what? 0. And dy dx is y prime. Grace.
I have a question about 88.
Yeah.
So if 88 is true, then how come 87 is false?
That's a good question. So 87 kind of says the same thing but backwards. So 87 says if f prime of x equals g prime of x, then f of x equals g of x, right? Well, it has to be with a constant.
But wouldn't it? But then the constant is just 0.
But it doesn't have to be. Like, if you had, say, f prime of x is 2x, g prime of x is 2x, what function has a derivative of 2x? X squared, right? So you could say f of x equals x squared. But g of x could also be x squared that. But it doesn't have to be x squared. Couldn't it be x squared plus 6? Or x squared plus 10, or x squared minus 11, or x squared plus pi squared. So when we do these if-then statements, it's if this is true, then this thing has to be true.
Okay, so if it's backwards, like if it's
yeah.
f of x, g of x, then f prime of x.
Yeah, if this is our if, and that's our conclusion, then it's a true statement. But this is called the antiderivative. The antiderivatives could be different by a constant, and then they are not the same. It's kind of like, in geometry, all squares are rectangles, but not every rectangle is going to be a square. All females are, all women are humans, but not all humans are women. I won't say all females, but like there are female dogs and female chickens, so that's not going to work. But you know what I mean. So it's the same sort of thing here. Like not every if-then statement is a two-way street. This one is just a one-way street. Any comments on 89? All right. Let's talk about the word problems. Let's talk about example 10 first. So Lucas, could you kill the backlight switch now? Thanks. So you're up on the diving board, and you have this equation for your height or position. And what's your initial upward velocity? So what's the 32? The height, so that's not your upward velocity. What's your initial upward velocity? What's V naught? 16. So V naught, initial velocity, is attached to your T term in these free fall problems. S naught is the constant. All right, so that's just understanding what you see in the equation. The T squared term is gravity, making sure you fall down. If we want to know the time at which you hit the water, what does it mean for our position when we hit the water? 0. So we say S equals 0. So you would take this whole equation and do what with it? Equal it to 0. Can you solve that? Go ahead and solve that equation now. It actually factors out very nicely. So take out a GCF and then you want to play with that. Yes. You need a new marker? Stop killing these guys. Can you toss me this, please? Your old one. That was our last marker, so we're out. I'll make one once in a while. Yes. Units, though. Great. Uh-huh. Okay, I can do that. That's good, that's good. If your marker dies and you can't use it, and I'm out, just do this in your notebook. And then analyze and assess your own self when we go over it. Because that would be your position at time 0. That's not height equals 0 when you hit water. That's how high are you at time equals 0 seconds after you've done, which is the moment. So if you want to know how high you were at the moment you hit the platform, then you plug 0 in. Good. Good. All right. So we end up hopefully with a solution of t equals 2. Any questions on how we get there? Yes. What's our GCF? 16, and since the leading coefficient is negative, let's take out a negative 16. So we're left with t squared minus t plus, minus 2. And then t squared minus t minus 2 factors down to t minus 2 and t plus 1, right? So we have a solution of t equals 2 and of t equals negative 1. We don't care about negative time. It's irrelevant in our world. So we just go with 2 seconds. Now, part B, we want the diver's velocity at the moment of impact. At what time is the moment of impact? No, at what time? The moment of, when you hit the water is the moment of impact. So what time is that happening? 2 seconds. You just found it. We want to find the velocity then at this time. How do we find velocity? Do the derivative, right? So velocity is s prime. So you would find the derivative and then plug into the derivative, and now you have your velocity at that time. So I think this was basically what was it, 99 was? Yeah, so this was very similar to 99, except in 99 they were doing things in meters, so instead of a 16 out front, you had a 4.9. Great. Mm-hmm. So that's the speed. The velocity would be negative, but otherwise, yeah. That is how fast you're going. That's good. Say again? Speed cannot be negative. Velocity can be. Speed is just how fast you're going. Velocity is how fast and the direction. So you can have a positive or negative direction. And so that's why velocity is allowed to be negative. But speed is just the pure how fast you're moving. So the speed would be 48 meters per second, feet per second, and the velocity would be negative 48 feet per second because we're moving down. And down is the negative direction. So if you got negative 48, yay. Any questions with getting the derivative? All right. So with 99, well, I'm just going to scroll here and give you guys another one of these. Yes, Prince. Yep. That's fine. Because I can see that you've done the derivative to get that. Where is the... Oh, it's... All right, next problem here, and last one up here on the overhead. So this is left and right movement instead of up and down, so we don't have like our usual negative 16ths. So then we have just, this is our position equation. So x is position now instead of s. Time is our input variable still. So that's our position. And we want to know what is the position at time equals 5 and what is the velocity at time equals 5. So you're going to find two things for me. Label position x and velocity v. So go ahead and find those two pieces of information at time equals 5. And I don't think I gave units, so don't worry about units. Just straight numbers. 24. Yes. Good. Good. With the derivative, what's the derivative of just x? There you go. That's going to change your velocity. That's what you want. So that's velocity. Oh, I realize there's a typo in that. It should be t squared minus t. Yeah. That's good. That's good. That's good. Let me fix that. You missed a board point opportunity, guys. If you were like, "What? I'm confused," and that's why, fair enough. So I can't highlight that. So those guys should be t's. Sorry about that. So what's our position when time equals 5? 24. So that's like 24 spaces to the right of the origin. And what's our velocity? 9. Because what's our velocity equation? Yeah, 2t minus 1. You probably wrote down 2x, but that's my fault. So 2t minus 1 is your velocity. At this moment, are we to the left or to the right of the origin? And are we moving to the left or to the right? So we're on the right side of the origin, and velocity is positive or negative. Positive, so we're moving in a positive direction, which is to the right. So you drew a number line, here's 0, the origin. You're way out here at 24, and you're moving to the right. Are we getting closer or farther away from the origin? Farther away. So that's like now we're taking what we had and turned it into an AP style question. We don't. I'm asking, does the particle ever stand still? We haven't talked about part B yet. We're still in part A. I'm taking what we've done in part A and expanding on it. Any other questions with part A? Let's go to part B. When does the particle stand still? So, what does it mean to be standing still? Yeah, so a lot of you said 0. I was like, that's really vague. So specifically, what's 0 for standing still? Velocity. Because velocity being 0 means we're not moving. So we have this equation for velocity 2t minus 1. And if we want to know, is the particle standing still, that's another way of saying, is the velocity equal to 0? So go ahead and find out if that ever happens, and if it does, when. It should be pretty quick once we've established what's going on. Yes, yes. Yeah. Oh, okay, that's 1/2. Thought it was like a headless stick, armless, legless stick figure being like attacked by a snake. Yeah, yes. So, yeah, you just say, all right, particle standing still means the velocity is 0, set velocity 0, solve for t, and t is 1/2. So, 1/2 of our time units, seconds, minutes, hours, whatever it is, we're standing still. Now, that might just be for a moment. Maybe we're changing direction at this time, and we're about to move back to the right, and we're moving to the left or something. But that's what that is. Any questions to follow that up now that I've erased everything? All right. Lucas, could you turn the light back on, please? And that can go away. And block 2 warm-up. So on the test quiz thing, whatever you want to call it, there will be a problem where you have to find the derivative using the limit process. So before you do that, real quick, what does the limit definition of the derivative look like? The normal one that we're used to. I'll help you out. It starts with the limit. Good. So one of the problems is, what is that? So know it. And I'm just going to ask you to regurgitate that back on the page. And then I'm going to want you to use it. So use this to find out f prime of x for when f equals root x.
What's the one with C called?
That's, the alternate form. So that'll be on the quiz as here's a limit, like yesterday's block 2 warm-up.
Yeah.
Here's a limit. It represents a derivative. What's the function and what's the c value? You'll have one of those as well.
So if we don't.
Well, yeah, so you'll have that. That'll be where the alternate form of the derivative shows up.
Okay.
But for the you got to work through it yourself, it'll be with this. So there's your setup, and then go through the process of actually taking. Yeah, I know it's not. Now the nice thing is that you can always check your work with this sort of thing, because you can do your power rule, right? You can rewrite it as x to the 1/2 to do your power rule, and then you'll know whether or not you did it correctly, because you can do your power rule to be sure. Good. Nice catch. So yeah, I want you to I want you to not just set it up, but then show me that you can work through the limit process. Yes, yes, yes. So this is going to be where I'm checking to see doing your steps properly, order of operations, and canceling things out in the correct order and all that, as well as setting up the derivative in the first place. So you get a point for setting it up right, and then you would probably get subsequent points for working through the process in the proper way. That's good. That's good. This is where you multiply by conjugate numerator. This is what we're practicing today. So that when it's game day, right? And now you can take the limit. So you've done all your algebra to the point where now you can actually plug 0 in for each term. And I think there should be a plus sign between those two radicals. I don't think that's plus or minus. That's good. That's a little bit right. Yeah, this is the limit definition of the derivative. Or sometimes it's called the definition of the derivative. And then the other version, where we have the limit as x approaches c, that's f of x minus f of c all over x minus c. And this doesn't give f prime of x, this gives f prime of c at a particular point. This is the sort of thing where you only have to look at this in the context of, here's a limit with an actual function hiding in there. Tell me the function, tell me the c value. And that's all you have to do. That's good, that's good, that's good, that's good. Let's work through it here. I'm going to start setting this up. So the limit of h approaches 0 of root x plus h minus root x all over h. And when you're dealing with a function involving radicals, what do you have to do to rationalize it? And so to rationalize it, you're multiplying by fancy 1, where the numerator and denominator are what? Yep, so you're multiplying by the conjugate of the numerator. Same two terms, change the sign between them. We only use that with radicals. So if you had a fraction situation, it was 1 over x plus h minus 1 over x, you're not using a conjugate, you're just using separate factors, and that would be a time sign here between them. So you multiply this out, you get x plus h minus x all over h quantity conjugate. The x's cancel out. Then as a separate step, the h's cancel out, because stuff in parentheses happens before you divide. You have 1 over the conjugate. So I'll finally write again. And now you can take your limit and have h approach 0. H goes to 0, and what's root x plus another root x? 2 root x. So there you go. So that's the process. So you would get a point for setting things up, and then you would get a point for at least showing me what you need to multiply by, and then you would get the remaining points for working through it. So there's a point, and there's a point before you've actually really done any work, and then the remaining 2 or 3 points is all the rest of it. Deb? And then you could label this, and you absolutely should label it as f prime of x. Yeah. All right, do the same thing with 1 over x. So new function, f of x equals 1 over x, do the same thing. Yes? Thank you, Laura. I'm all out. I gave out all the, I guess I could give you my own, nasty rag here, which isn't really any grosser than what you guys are working
One thing.
with. Oh, yeah. Yeah, this doesn't need to be turned. Nope. Real close. Real close. Just be careful when you distribute that you don't lose track of a tiny little detail. Oh. So, you're processing. You're missing a negative. You are also an x times x squared. So
Oh, I forgot
that negative distributes. Yeah, otherwise you're good. Good. You're missing a negative. That's good. That's good. So, yeah, this one you got to be careful when you distribute your fancy 1 through, that this negative gets distributed through the x plus h. That's what people are going to be most likely to mess up. That's so you also miss the negative. So this whole x plus h is getting subtracted, not just the x. So yeah, you want to shoot the numerator out. This thing plus here, x plus h cancels.
Give you function.
I always use the
Good. I will want you to show the separate steps of like canceling out the x's, putting up the numerator, and then dividing out the fraction. Those are technically not the same step. Yes. Negative. So, what's our fancy 1 this time? X plus h times x, not plus x. So this is not a conjugate situation because we're not dealing with radicals. So these two things you're multiplying by are factors getting multiplied. You take this whole thing, you distribute it through. When you multiply it to the first half of the numerator, who cancels out? X plus h's, and you're left with a 1 times an x. When you multiply this to the second half of the numerator, what cancels out? And you're left with a negative 1 times the x plus h. A lot of us are forgetting that negative. So negative 1 times the x plus h gives us a negative 1x and a negative 1h. A lot of people are forgetting that the h is also negative. And then this is all over h quantity x plus h quantity x. The x's cancel. As a separate step, the h's divide and cancel out and make negative 1. And now you can take your limit and have h run to 0. And what's x times x? X squared, so not 2x. So that's your f prime of x. Comments, questions with that? Oh, why is it all? So I was showing an example of what free fall can look like in my block 3, and I got carried away. Because free fall can be just you toss it, or you drop it, or you chuck it down at the floor. So that's like a difference between initial upward velocity, 0 velocity, and negative initial velocity. And I got, really into the negative initial velocity because I was imagining it was like a freshman or something. And like I wish the freshman would do, it broke. Sorry. Oh, I shouldn't say that stuff when I'm getting recorded. Any Nerose? Yeah, right now, actually. So, this thing, these K problems, they're tough. What are the two main facts we need to keep in mind as we do these nasty old K problems? Y equals f of x equals y, and? Yeah, derivatives equal slopes. So, y equals f of x. We have something about y, it's 5x minus 4, and we have something about f of x, it's x squared minus kx. And then you look at that and you say, Nope, can't solve it and don't want to. So then you come over here and you say, what's the derivative of f? 2x minus k. And what's the slope of the line? 5. So there's your second equation. And you say, well, I can't solve it, but I can isolate one of these guys. Who's going to be easier to isolate, x or k? Okay, so let's isolate k. So we're going to add the k over to the right and subtract the 5 over to the left. So I have k equals 2x minus 5. So now I know something about k. I don't know the value, which is what I want, but I have it in terms of x. So what can I now do with this k? Substitute it into the other equation for k. So over here we have this equation in what's basically two variables. K is technically a constant, but we don't know what it is. So it's, in a sense, it's a variable. So we're going to swap out k with what we know it is. Oh, now we know it's 2x minus 5. So now I'll have 5x minus 4 equals x squared minus k is 2x minus 5 times x. And now we algebra this thing. Distribute out the right side. So 5x minus 4 is just going to be chilling for a moment. X squared. And what's negative 2x times x? And what's negative times negative 5 times x? Plus 5x. And now we try to solve it. 5x, what happens with this 5x? It's gone because we have exactly the same term on both sides of the equation, so they just cancel. Then negative 4 has no other constants to get with, so we'll just let them be for the moment. And then what's x squared minus 2x squared? Yeah, negative x squared. So you solve this, and what's x? 2 plus or minus, because we have x squared equals 4, square root both sides of an equation yields 2 solutions. So this one's especially nasty because you end up with 2 solutions for x, which means you're going to end up with 2 solutions for k. So now that we know what x is, guess what we can do with them? Put them back in over here and find out k. So for x equals 2, we could say k equals 2 times 2 minus 5 is negative 1. And for x equals negative 2, we could say k equals 2 times negative 2 minus 5. And that's, thank you, negative 9. So, ta-da! Ryan.
Before you find out what your x values are, bring the x squared and negative x squared to the other side.
I'd say this is x squared minus 4 equals 0, and then factor x plus 2 and x minus 2. Absolutely. Could you do it the other way around and bring the negative 4 over here? Yeah. I don't like that because then it leaves x squared being a negative. And I don't like my variables to be negative because I'm neurotic. But yeah, you could do that. Any other questions? So y equals f of x, derivative equals slope. Set up what those equations look like. Isolate whoever's easier to isolate, and then substitute that over here, and you can then algebra. Should we work through 67? Yeah, let's work. So same basic idea, right? We have these two relationships, y equals f of x, and slope equals f prime of x. So what's our y equals f of x equation going to be? So k over x equals negative 3/4 x plus 3. So basically, function equals line. You could also say it like that. Slope is negative 3/4. Derivative, what's f prime of x? K, x negative 1, so that's negative k, and then over x squared, so negative k over x squared. And then who's going to be easier to isolate again? Probably k. So to get k by itself, what do? Multiply x squared over, and then divide by the negative. So you have k, it's x squared. What do you do with it? Substitute over here for k. So now over here, we say k is going to turn into 3/4 x squared all over x, which looks a little awkward, but it'll clean up real nice. And then over here we have negative 3/4 x plus 3. What happens with this ugly? Cancel out x's, so now we just have 3/4 x equals negative 3/4 x plus 3. Now you can algebra that. Add the 3/4 x over. What's 3/4 plus another 3/4? 3/2, so 6/4 is 3/2. So you have 3/2 x equals 3. And so what's x going to equal? 2, right? Because you multiply by 2/3. So then once you got that, find k. Ah,
Since negative 3 over 4 is equal to negative k over x squared,
yeah.
we just have automatically k is equal to 3, and x is equal to positive negative 2.
Well, it turns out not negative 2, but otherwise, well, I think we end up, like when we solve it, we don't get positive or negative 2. So I'm wondering, why does that not show up? What did the answer key say? Just 2? Okay. So, yeah, I don't know why that reasoning doesn't work totally, but it definitely gets you that k equals 3. Probably it has to do with the tangent line. There's only one line. If there were 2 lines, that maybe then it would work. But yeah, that's another way. You could reason that through and say, well, k equals 3, x squared equals 4. Maybe you don't know what x is, but you know what k is, and that was the goal. So that's another, yeah. I hadn't thought of doing it. That's a hell of a lot easier for that one.